Okay, welcome back to math class, and welcome to 9-6. So far, we've learned about linear functions, quadratic functions, and exponential functions. Today, we're going to talk about how to look at data and figure out which one of those three things it is. So, what I'm going to do is just make a huge chart for us to compare linear versus quadratic versus exponential. Okay. Now, in a linear function, you remember the standard form of our linear equation was y equals mx plus b. The root of that is just a y equals x to the first. Anything where our x's exponent is just 1. In a quadratic, we get y equals ax squared plus bx plus c, and we see that the root of a quadratic is going to be y equals x squared. You can tell something is going to be a quadratic equation if it has an x squared in it. With an exponential function, our root function is going to be y equals ab to the x. Anything that's a number raised to the exponent will be an exponential function. Now, when we're looking at a graph, we can tell pretty easily which one of the three it is, because a linear function will always look like we have our x and our y-axis. A linear function will always be a line. Every time it's going to be a line. If you see a graph that's a line, you know that it's a linear function. With a quadratic function, when we look at its graph, it's always going to be a parabola. It could be up or down, but it is always going to be a parabola. So if you see a graph and it's a graph of a parabola, you should automatically think in your head, this is a quadratic function. With an exponential function, it's always going to be an exponential curve. If you see a graph and it's plotting an exponential curve, you should automatically think in your head, this is an exponential function. So looking at the graph of something, you should automatically be able to tell by looking at its equation or by looking at its graph, you should be able to know whether it was linear, quadratic, or exponential. There's one more test that we can use to decide whether or not something is linear, quadratic, or exponential, and it's called successive differences. And basically how we're going to do this is by, I'm just going to shorten this a bit, looking at a table of values for this equation. So let's start with linear. If we have a linear function, we have a table that's all of the points in this function. So my x values are 1, 2, 3, 4, and my y values are 5, 10, 15, 20. So when I'm looking at a linear functions table, when I go through and I find the difference between each term, it should be a constant rate. What that means is, looking at this, the difference from 5 to 10 is plus 5. The difference from 10 to 15 is also plus 5. The difference from 15 to 20, also plus 5. Now, so because this is a constant rate, the first time we took the difference, this is a linear equation. So the first difference is a constant rate. Now with a quadratic function, this won't be the case. Let's make our table of a quadratic function. Oops. Okay, 1, 2, 3, 4 again. With a quadratic function, they won't have a constant rate of change in the first difference. So let me fill in our values. Okay, looking at this, when I do my first set of differences, the difference from 8 to 17 is going to be plus 9. The difference from 17 to 32 is going to be plus 15. And the difference from 32 to 53 is going to be 21, plus 21. Okay, so that's not a constant rate of change. We're not adding the same amount each time in our first difference. What's unique about a quadratic function is if I take a difference a second time, it will be a constant rate of change, and I'll show you what that means. If I now look at the difference between 9 and 15, the difference from 9 to 15 is plus 6. And the difference from 15 to 21 is also plus 6. So in my second set of differences, it is a constant rate of change. So this is a quadratic function. It's this on the second difference. So with a linear function, it's the first difference of the y values. In a quadratic function, we take our difference, and then we take a second difference between those numbers. And if that's a constant rate of change, then it is a quadratic function. With an exponential function, let's make another table of values. Let's go 0, 1, 2, 3, 6, 12, 24, 48. If I find my differences, the difference between 6 and 12 is plus 6. The difference from 12 to 24 is plus 12. The difference from 12 to 48 is plus 24. So that first difference is not a constant rate of change. Let's try our second differences. From 6 to 12 is plus 6. From 12 to 24 is plus 12. So that's still not a constant rate of change in my first or my second difference. So when I look at this, I know that it's not a linear function because the first difference was not a constant rate of change. And I know it's not a quadratic function because the second difference is not a constant rate of change. So I know that it's an exponential function by our process of elimination. That's all you need to know for this lesson. You need to be able to recognize based on the equation, based on a graph, and based on a table, whether you have a linear, a quadratic, or an exponential function.